fun begins here. Exam 2, this is where we begin. And I'm actually going to start out with section 2 today, just because I feel like if we leave that for the end, we'll all be pretty stuffed. In the real exam, do the multiple choice part first. It's a good feeling to get some runs on the board. And also feel like you can get to section 2 ahead of time, so you have more time than you think. That always helps. So let's get into it. And we are just going to rip into section 2, question 1. So let's do it. Real good. Okay, so you get given a graph on section 1, on question 1, and it's a log, and you go, great, okay. And the first question is, they want you to look at the rule, or to find the rule and domain of G inverse, the inverse of G. Okay, so you all know how to do that, right? You all know what to do with an inverse. 1A, part 1. Okay, so you know that to find an inverse, it's pretty easy. X is 2 log y plus 4 plus 1. And you can shift that around. You can get x minus 1 on 2 equals log of y plus 4. And then you can say, great, y plus 4 equals e to the x minus 2 on 1. Y equals e to the x minus 1 on 2 minus 4. Okay, that part's the easy part. Talk about the domain. What is the domain? Notice that the domain of your function, of the inverse function, is going to be the range of the original function. Look at the original function. What's the range of the original function? Well, it goes all the way at x equals, when it gets close to minus 4, you see it goes all the way down, right? Negative infinity to, goes all the way up. It's a log function, but the range is R. So, domain is R. No limit on the domain. And if you look at the function, it makes sense. It's exponential, right? Defined for all values of x, just like our log function was defined for all, worked for all of its values. So we didn't actually cut our log function anywhere. So we can be very happy about that. A part 1 out of the way. Okay, so draw G inverse. So, okay, so I can't actually draw on this thing with my tool. What I can do is draw that graph for you. So this is our graph. G inverse looks like this. We've got our asymptote at x equals minus 4. And we sort of do this, right? So that's f of x. Okay, what's going to happen for our inverse? Well, we also need an asymptote, this time at y equals minus 4. And we sort of go through like this. Like that. And also they ask you to label the axis-intercept with the exact values. Really easy. So basically, look back to question 2. I mean, you could just graph the thing and get it. But typing into the calculator takes time, and it's sometimes easier to just look at the working you've done. So, okay. So the y-intercept is what happens at x equals 0. So at x equals 0, what goes on? Look at the y. You'll get e to the half minus 4, right? So at x equals 0, so here, this point, you'd say 0, e to the, minus half, minus 4, And this point here, the x-intercept is when y equals 0. So go to the very top line, you'll see x equals 2 log y, etc. And you'll go, great. Well, at the x-intercept is 2 log 4 plus 1. There, labeled. Sorry, I don't mean to draw like open circles or anything like that. I'll color them in. There. Easy, isn't it? Okay. So on to part 3. And unfortunately, this part you will need to use a calculator. Find correct to 3 decimal places where g dash of x equals g of x. Okay, first of all, you know that you're looking for 2 answers because you see the graph intersect twice, right? So you could do this. You can go, well, let's just equate the 2 together. 2 log x plus 4 plus 1 equals e to the half x minus 1 minus 4. Get your calculator to solve that. You should all know that. Or you could just equate either one of them to x, because you know that all of their intersections are along the line y equals x. Sorry, I can't draw this line straight because I haven't exactly drawn the graph entirely correctly, but this is y equals x. And you know that too. So you could equate that equation, or you could equate one of them to x. Hey, that might be shorter keystrokes, give you some time, but either way, you're going to get x equals negative 3.914 or x equals 5.503. So yeah, the calculator does the grunt work for you. Part 4, find the area enclosed by g and g dash. Okay, cool. Again, set up the equation, set up the integral, and then worry about that later. So you know the integral is from the top to the bottom. So obviously the bottom is negative 3.914 like you found in the last question, and the top is 5.503. And then you can do, well, top minus bottom, right? 2 log x plus 4 minus, plus 1, and then minus e to the half x minus 1 minus 4 dx. Simplify that a bit. 4. You can simplify that to 2 log x plus 4 minus e to the half x minus 1 plus 5 dx. And of course, that's definitely for your calculator, and you'll come out with 52.63 as your area. So again, we're not interested so much in the answers. The calculator takes good care of that, I believe. But essentially, it's in setting up the questions, setting up the exams, setting up your equations. Notice that you could have done as well. You could do the log curve minus y equals x, and then multiply that area by 2. That would work too. Perhaps there would be fewer keystrokes too. So think about that. That could help you. But yeah, an approach so far would be really good. So on to part B. Well, this is a big question. So 1B goes, you've got a diagram. It's a log. Great. And you get a few little questions. So you get 3 little facts, right? Like the graph has a vertical asymptote here, the graph has y-intercept here, and then there's a P point where it's got coordinates P10. So then you go, great. First part, state the value of A. Should be able to do this without thinking. You know what A has to be all about, right? A is about the asymptote. And so if you have an asymptote at x equals minus 1, that means the inside of the log has to equal 0 at x equals minus 1. A equals 1. that should be something that you don't need to think very much about at all. Part 2, value of C, okay? Using the second point of info. Sorry, I should scroll this down. Forgot about that part entirely. Okay, good. Now all of you can see the question, for those of you who don't have the questions in front of you already. Second part of B, you say, okay, good, y-axis. The y-intercept is 1. Well, that's really good, because you can just put in the equation, right? You know that f of x equals k log x plus 1 plus c, right? At the y-intercept, you know that y-intercept is 1. 1 equals, well, log of x, or x equals 0, so you get log 1. That whole term goes away and you get c equals 1. Great. Hanging along awesome. Third one. Show that k equals 9 over log p plus 1. Okay, so there's no obvious way to just look at it and go, yay, I can do it. But perhaps you need the third point. See, they're nice to you in these exams. They give you 3 little bits of information and then 3 little subparts that each one will use 1 bit of information. They're really wanting you to succeed here. And this is where you use the last point. The point P is P10, where P is another real constant. So you say, great, the graph must pass through P10 then, mustn't it? And you say to yourself, okay, good. I know a bit about f of x now. It is k log x plus 1 plus 1, like so. And then you sub in P10. So 10 equals k log p plus 1 plus 1. Oh, look. Does that just like make your life come together nicely or what? So you get 9 equals k log p plus 1. K is obviously going to equal 9 over log p plus 1. There. Again, not very hard, right? Not too difficult. We're happy. Part 4. Show that the gradient of the tangent of the graph of f at the point P is some expression. Okay? Don't be fooled by the expression. Sorry. I'll move it around. Point 4. Don't be fooled. Just find the gradient of the tangent, the graph at the point P. Gradient of the tangent to the graph at point P. You can take away the tangent. Gradient of the graph at point P, because the gradient of the tangent is the same as the gradient to the graph. Gradient at point P. So what it's asking for is f dash P. Right? So just find yourself f dash P. So maybe the first thing to do is find f dash of x. Now f of x, like you know, it is k log x plus 1 plus 1. You found k already. F dash of x is going to be k on x plus 1. Notice I'm not hugely enamored about putting in the real value of k. I know what it is. I'll sub it in at the right time. This saves time. Okay, great. So then you say, well, f dash of p equals k on p plus 1, right? So maybe this is a good time to put in k. K p plus 1. Oh, it pops out, doesn't it? Look. 9 over p plus 1 times log p plus 1. Just like what the question says. So good, isn't it? So good. Okay, B part 5. I'm going to tell you a little bit about B part 5. 64% of everyone who did the exam last year got 0. Because it's not immediately obvious what you should do. It says if the point negative 1, 0 lies on the tangent referred to in the last part, find the exact value of P. Okay? That's it. Find the exact value of P. Find the exact value of P. How do you start? When you don't have a clue, several things you can do. Draw diagram is a really good thing to do. Draw diagram. So I would draw this just on the exam booklet, but since my thing doesn't actually let me draw on it, I'll draw the graph here, and I'll just explain how I would think about the question. About that. So this is my curve. It does this, right? I know that this asymptote is at x equals minus 1. I know that I have some point P, P10. Okay, so far nothing new has happened. So far nothing new has happened. I'm just copying the graph from the exam paper. Okay, and now you say that this tangent P, at P we've got a tangent, right? And now this tangent happens to go through this point. This point is -1, 0, like so. I know I haven't drawn the tangent very straight and stuff, forgive me. But do you see that our tangent has to go through P and has to go through -1, 0? What does that tell you? It tells you that, well, we've got some points on the tangent. Good. You can think about it as though, you can think about it like, well, okay, good. We have somewhat a triangle thing going, don't we? What does a triangle remind you of? Maybe some rise and run stuff. So at this point, when you don't know what's going on, all you're looking for are some facts. You always look for facts. Facts when you're not sure what's going on. Okay, fact. Think of facts. First fact is that the gradient of the tangent at point P is the same as the gradient of the curve at point P, right? That's why it's a tangent. Yeah, you know that. 2, you know that this tangent goes through -1, 0 as well as this point. It feels like you've got a lot of knowledge about this tangent. In fact, you know exactly the gradient that the tangent has, right? So I'm going to call MT the gradient of the tangent. You know what it is? Rise and run, right? What's the rise here? P, no, sorry. The rise here is 10. Yeah? So we go from y equals 0 to y equals 10. What is the run? It is P minus -1. We go from x equals -1 to P. So P plus 1. We know this has to equal f dashed P, right? Because that's the gradient of the tangent. Okay, cool. Now what? Now we say, good. What's f dash P? Well, you know what that is. You found that out in the previous question. 9 over P plus 1 log P plus 1. Oh, look. Here we have it. An equation that you can solve for P. The crucial step, this one. That's the superstar step, where you equate the gradient of the tangent to the derivative of f at P. Are we all pretty clear on how we got there? Yeah? Hands up if you're not. So look. Okay, a couple of you. Okay. So very clearly, very simply, we know what we're happy that the derivative is the derivative at P, right? That's what the tangent is based on. So these two gradients must be the same. The gradient of the tangent is the same as the derivative at P because the tangent was taken at P. They're like the same thing. So we just equate the two. And it so happens that we know a little bit about 2 points on the tangent, so we can find the gradient of the tangent, and so we come out with this equation. Once you have this, you can see that you can cancel off P plus 1. You can shift things around to get log of P plus 1 equals 9/10. And you'll see from here that P equals e to the 9 on 10 minus 1. There. All done. Pretty good? Pretty happy, right? Not many students got that. To be honest, when I first did it, I didn't see the solution immediately. But what do you do when you don't see solutions immediately? You write down facts, you can draw diagrams, you write down, try to formulate things around what you know. And a lot of the time, the answer will pop itself out. Awesome. So that's what we've learned out of question 1. Let's move it on. Question 2. Question 2 is about Markov chains and Victoria Jones, Tasmania Jones. They've appeared on numerous exams. Question 2. Okay, so they're making statues, and there's 2 classes, superior and regular, and the probability depends on, or the probability of this statue being superior depends on the probability, or depends on whether the last one was superior or what. Okay. First thing you need to do, have a quick look at what the first part wants you to do. It goes, if the first statue inspected is superior, find the probability that the third statue is regular, and P equals 0.9. Okay, classic kind of Markov chain question. All you do, you can draw the transition matrix. Okay, what goes up the top left? Let's say that's, you can do like success, failure type things. But let's call, superior success, regular is some kind of failure. And so P is 0.9, meaning that if the last statue was superior, this statue would also be superior. That goes in the top left. And so naturally, get 0.1, right? So 0.1 means if the last, 0.1 is the probability of this one being regular given the last one was superior. Okay, move across to the other side, and you know that if the statue is regular, then the probability the next statue is completed is P minus 0.2. So bottom right, this is, what's the probability of this one being regular given the last one was regular? And so the top has to be 0.3. That's our transition matrix. Okay? Now notice that we have the first and we want the third. What does that mean? That means that we've got 2 in between. We're testing, it's like we're going 2 links down the chain, not 3. So we're doing this experiment twice, and we know that the first one was superior. Superior is top, remember? Do that. Stick that in your calculator, and you're going to come out with 0.88 and 0.12, I believe. And so the top 0.88 is the probability the third statue is superior. The bottom is the probability the third statue is going to be regular. And so that's what we're interested in. So we can say PR regular is 0.12. Done. Straightforward. Quite straightforward, actually. Okay. B. If the first statue inspected is superior, find the probability that the next 3 are superior. So the next 3 meaning the second, third, fourth. Now this is easy because you know that if one is superior, the next one must be superior. The probability of the next one being superior is 0.9, right? So what's the probability of the second one being superior? 0.9. What's the probability of the third one being superior? 0.9. Fourth one, 0.9. There. Not a Markov chain at all, actually. It's because you assume they're all superior. So what's the probability of being superior given the last one was superior? It's just 0.9. That shouldn't trip many people, I hope. Steady state probabilities. Okay, very simple. There's a formula for this. You'll know it anyway. Right, you get A over A plus B. What's A? This one is A. That one is B. Yeah? Sorry. Take a small break. Yeah, A and B. There you go. So you get A over A plus B, which is 0. Ooh, what have I done? What have I done? Doesn't look right. Does not look right. Does not look right. A is, okay, A is the probability that we're superior given that the last one was regular, and B is probably that we're regular given the last one was superior. So you should have 0.3 over 0.3 plus 0.1 gives you 3/4. 3/4. Okay. What does that mean? Well, you all know what that means. It means in the long run, doesn't matter what you start on, you're going to finish with 3/4. There's a 3/4 chance of you having a superior one. Doesn't matter what you start on at all. Actually, sorry, I've drawn this thing completely incorrectly. Forgive me. 0.7 is supposed to be up here. 0.3 down here. I've misread the question. Sorry, but I did prepare, so the answers for part A are still correct, but the 7 and 3 are swapped around. The 0.7 represents a probability that you have superior given that the last one was regular. And so, you know, that's what I was not happy about. It's like, this doesn't look like the answer I had. So that's 0.7 over 0.7 by plus 0.1. So that's 7 on 8, not 3/4. My apologies for that. Okay, so that's the steady state probability. Anyway, part D, the first one. You're asked to find P here. You're asked to find P. So the easiest way is to say, okay, good. Let's write the equation down in terms of P. So again, we write our transition matrix, but this time in terms of P. You know that top left is the probability that you get superior given the last one's superior, so that's just P. And so that means below that you get 1 minus P. And here, the top right, it's P minus 0.2, right? And so the bottom, you get 1 minus whatever's on top. So 1 minus P and then plus 0.2. 1.2 minus P. All right, again, you know the first one and you're interested in the third one. Square, remember you're doing this thing twice. You know that the first one is superior. The probability of the third statue being superior is 0.7, like that. So you solve for P. Do that with your calculator. We all know, we're all happy how to do that? Well, actually, I wouldn't be able to help all of you anyway because we all have different calculators. But yeah, your calculator can do that. And you'll find that P is 0.75, just as the question suggests. And everyone is super happy. Okay, D part 2. I want to tell you something about D part 2. Only 10% of students got all 4 marks. What's so difficult? Well, you want to find, look, read the question carefully. It goes, find the expected number of these 3 statues that will be superior. And she goes, okay, 3 consecutive statues inspected. The first of the 3 is regular. Okay, cool. The first of the 3 is regular. So you're looking for expected number. So what does it say to you? It means draw. You got a discrete distribution, don't you? Because what are the possible values? You get 1 superior, 2 superior. Possible get 3 superior? No, because the first one was regular already. You can only have 0, 1, or 2. So you want something that looks like this. 0, 1, 2. Yeah? Fill in the probabilities. What you want to do is fill in the probabilities here. Great. So, go for it. Probability of 0 on this day. Okay, so you want to find the probability that you get 0 superior ones. So you just get regular, regular, regular. Maybe it helps first if I just draw this thing out, given that I know what P is. Right, so P is 0.75. So if you sub 0.75 above, you get 0.575, 0.55, and then 0.25, 0.45. Good? Okay. So, probability, and you want to find, actually no, and you want to find E of X, right? E of X is, what? 0 times the probability of X equals 0, 1 times probability of X equals 1, 2 times probability of X equals 2. Notice that you don't need to calculate 0. It's just PR X equals 1 times 1 plus PR X equals 2 times 2. So just find 1 and 2. Don't bother about 0. Okay, so here comes the interesting part. Probability of X equals 1. Right, so we get PR1 means 1 superior out of the 3. You know the first one is regular. So you could have, okay, let's just write down the possible ways of doing things. Superior then regular, or, notice that we do plus for or regular then superior, okay? So to be clear, second, third. Yeah? We know the first one already. We're not trialing the first one. The first one is regular. That's what the question tells us. So we want superior second, regular third, or regular second, superior third. Let's look at the probability of either of these. Now, you know that the first one was regular. For the second one to be superior, 0.55, yeah, superior given regular. 0.55 times, now, the third one, you want regular given what? Superior, right? 0.25. Regular given superior. 0.25. Plus, okay, regular. Regular given regular, because the first one was regular, is 0.45. Times superior given regular, 0.55. That comes to 0.2025. Easy, hey? probability of x equals 2 is, well, that means you want both of them to be superior. So the first one is regular, you know that already. You want the second one superior and the third one superior. Okay, the second one superior. Superior given regular, right? 0.55 times superior given superior, 0.75, and that's 0.385. So E of x equals 1 times 0.2025 plus 2 times 0.385 comes out to 1.21. Final answer, 1.21. Happy about this? We're good? So you see that this question was tricky in a way because it didn't use the transition matrix or anything like that. And also it made you find these specific probabilities, and you had to know what you were looking for, right? The key is this part here. You have to think about, oh, that's what I'm looking for. I want a discrete distribution kind of table. I want different probabilities and then get that. And you get that by realizing that it says in the question, expected number. The key words, expected number, expected number. Be that 10%. Read the question, infer from the question what you need, work backwards to find what it is that you need to get. Be smart about how you work things. For instance, don't find probability of x equals 0. It's pretty pointless. And you're going to be in that 10%. Okay, we're not done with question 2. We're on 2E. All right, 2E is about another company making statues, but they're machine made, so it's not a Markov chain. It's a binomial distribution, right? Each statue made is a trial, except these guys really suck because what they're making is that the probability of the statues being regular is 0.8, and these guys want to make sure that they make at least 2 statues in a day with a probability of 0.9. So find the minimum number of statues that you need to make to achieve that aim. Okay. So this is one of these questions that you're asked to find n. How many goes does it take for this probability to become like something like above 80%, above 90%, etc. Right? So maybe let's characterize this binomial thing. So you know that it's for binomial, n choose x, where n is the number of trials, x is just the probability of you getting a certain number of superior statues. Notice I'm going to make success superior, right? So the probability of success is 0.2 on any trial. You have x successes. Probability of failure is 0.8. You have n minus x failures. Okay, that's that, right? And what are they asking you to do? They're really saying find n such that so you want to increase n to an extent that the chance of getting no superior ones or one superior one is below 0.9. Sorry, below 0.1, because you want the chance of getting 2 or more higher than 0.9, right? So 0 or 1 lower than 0.1. So find n such that probability of x equals 0 plus probability of x equals 1 smaller than 0.1. Interpret question. This is the interpret question part. And I'd say that this is the key step. We all happy about that? Yeah? Good? No big questions yet? You guys are pretty quiet, but that's all right. Hope you're enjoying yourselves. So, yeah, that's all you need to do. So let's write down what exactly we have, right? Point 1 has to be bigger than. Now, x equals 0, meaning you get no superiors. Failure rate, look, probability of failure is 0.8, right? So then 0.8 to the n. So that's probability of x equals 0 plus probability of x equals 1 is n choose 1 times 0.2 to the power of 1 times 0.8 to the power of n minus 1, right? Simplify that a little bit. N choose 1 is n times 0.2 times 0.8 n minus 1. You can solve that with your calculator. You'll find that if you do an equality, if you did an equality, you'd get n equals 17.94 something, right? Meaning that, well, if you want it exactly 10%, then you should do 17.94 trials. Should you round up or down? Remember, you're not always looking for the closest. You can see that as you increase n, your chances of success go up, right? But remember, for them, like, to win means to make at least 2 superior statues. So if you make 100 statues, surely you get 2 in there. But if you only make 3 statues, then it's pretty unlikely you get 2 good ones. So as n increases, as n increases, their probability of being happy increases. And so this sum, as n increases, this thing actually decreases. And so you're after n equals 18, you should round up. The more trials you do, the smaller this probability will be that you have zero good ones or 1 good one. And that's what you're interested in. So there you go. Part E all done. Again, it's a standard kind of question that you would have seen in your textbook, that kind of thing. There's no reason why people wouldn't get that right. But again, only 15% got full marks. Disappointing, I think. Disappointing. But I'm pretty sure that's not going to be any of you guys, because you guys are doing awesome so far. Okay. I'm interested in fighting on to question 3. Question 3 is about calculus type extended response questions. More than one of you said that this is the kind of question you don't like. I'm going to make sure that you guys have a good time. I'm going to show you that it's not too bad. So you get these pyramids, square pyramids, where all sides are 10 meters. 10 meters. There you go. Not very big pyramids. Not a rich civilization, but that's cool. And they're going to guide you through a process of sorts. So you look at the diagrams and your stuff, and you're like, okay, good. See what's going on. And you see that on one face you get this, or on all the faces, but you just get to look at one face, that you get this angle X that controls how tall or how small your pyramid is. X is between pi 4 and pi 2. Notice that the diagram on the left, the 2D one, it's not a cross section. It's one of the faces. It says there. Don't think cross section. If you think cross section, you're going to get everything wrong. You get 0 out of however many marks this thing is. So find AB in terms of X. Not too difficult. You know that ZB is, okay, you know that the side is 10, right? So WB is 10. So ZB and X, ZB is 10 cos X, right? Know your trigonometry from year 10. And AB is just twice of that. So AB is 20 cos x. A couple of little warm-ups to get you happy. Find WZ. Okay, WZ, again, use sine this time. 10 sine x. So yeah, this part shouldn't be too difficult. Shouldn't be too difficult. We're not up to the fun bit yet. 3b. Find the total surface area. Oh, easy. 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 You know how to find areas of triangles, right? Area is half base height. And that's why they got you to find ZB and WZ. Because WZ is the height, and sorry, not ZB, AB. AB is the base. So, area total is, now you got 4 faces, right? Square pyramid. 4 times half of the base. What's the base? AB is 20 cos x times the height, 10 sine x, plus the base. The base is just 20 cos x, AB, and then squared, right? So 400 cos squared x. And then you sort of just change that into what they want to see. Good. So combo that a bit, you get 400 cos x sine x plus 400 cos squared x. And that's just going to come out really nicely because you can take out your 400 like they want, and then you get cos squared x plus cos x sine x, just like what they want. There. 2 marks are for you, are yours for the taking. You have to like show questions because you know immediately whether you're right or wrong. There's no hiding it. Cool. C. Find WY. WY, the height of the pyramid in terms of x. Okay. WY. So now you need to start looking at, okay, where is WY? It's on the inside of the pyramid. And you go, great. What do I know that can connect myself to WY? And what's going to be smart is if you can connect this to what you already know, right? So WY, you know that, think about it. You know WZ, yeah? You know YZ, so the length of one of the little base bits. Draw yourself a diagram. Draw a diagram time. So this vertical part, WZ, sorry, WY, like that. And so this is like a cross section of the pyramid now. So you got WY, WZ at the bottom, and then, oh crap, sorry, that's not WZ. That's YZ, like that. Actually, you guys can't see that. YZ there, and then WZ here. Got this triangle going on. You can see what's going on, right? So this is a cross section. You know that WZ is 10 sine x from previous question. You also know that YZ is just the same as ZB, which you also got from a previous question. 10 cos x. Yeah? So, use some good Pythagoras. WY, which is the height. Now you know that this squared is equal to WZ squared minus YZ squared. Yeah, we can all see that, right? Cool. WZ squared is, so wy is square root of wz squared 100 sine squared x minus yz squared. Yz is 10 cos x minus 100 cos squared x. You can take out a 10, right? Take 100 out of this thing. And then sine squared x minus cos squared x. Make your life simple. Yeah, could do that. You can make your life simple, or you could just leave it. I'll leave it for now. Sine squared x minus cos squared x. Remember that sine squared x equals cos x cos squared x. You can transform that whichever way you like later on, and you will probably later on. So yeah, there you go, 3C. Again, nothing too difficult so far, but 68% of people got 0. Unacceptable. In fact, question 3 was actually very, very poorly done. And I think of the total marks, which was like 13, the average was about 5 out of 13. That's not very many, given that the first 2 marks are essentially free. And this is one of those questions that, as it wears on, more and more people gave up. This is probably the toughest question on the exam. So, but hopefully you can see that by finding the way we found wy, the height, was that we tried to relate it to what we know. Again, we drew a 2D diagram to understand what's going on. And we wrote down facts, things that we already knew, like WZ and ZB and so on. There's a method to it that makes life much easier than it is for other people. So yeah, part D. So you want to find the volume. Cool. Good. And then show that volume is T, is something. Okay, so V is usually used for volume, but they want T, so we're going to call it T as well. They're right. First thing you do, write down the volume formula. 1/3 area times height. Right? Area of the base, well, we know that already. 400 cos squared x times the vertical height. You found that in the last question. It is 10 root sine squared x minus cos squared x. Okay? Very good. So you can shift this thing around. 4,000 on 3. Let's just collect up these little bits. And then you see that the rest, look at the volume, look at the volume formula they want you to have. The rest of it is inside that square root, and also there are no signs inside the square root. Currently we have sign inside, right? So that's not desirable. What can you do to get rid of sine squared? Well, maybe a smart thing to do would be to use the Pythagorean entity. So you know that sine squared is 1 minus cos squared. So let's do that. Sine squared becomes 1 minus cos squared. So you get 1 minus 2 cos squared x. By the way, this thing's worth 1 mark. It's not supposed to be hugely difficult. But 78% of people got 0 for this one. Probably a lot of people gave up at the last point, which is fair enough. You can't do this one without the last one. Okay, now all you do is put that cos squared outside the square root back inside. So that becomes cos 4 inside, right? So you get cos 4, cos to the power of 4, x minus 2 cos to the power of 6 x. There you go. Volume found. Excellent. E. You want to max volume. Okay? I'm going to max volume here. So, it says to you, find the TDX and hence find the exact volume of this pyramid and the corresponding value of x. Ooh, talk about something tripping you up. The TDX smart among you will just turn straight to the calculator. And also, if you were to look a little bit ahead, you'll see that part F also requires this T formula, and it would be wise for you to put T into your calculator to store it. So if you were to go ahead and store T in your calculator, then you say, great, got T. So they want you to find the TDX, and so you do. And if you do it correctly, and it's not difficult to do correctly, you'll get 800 cos x sine x 3 cos squared x minus 1 all over 3 and then root 1 minus 2 cos squared x. Okay, cool. That's the TDX. That's the first part. Okay, find the exact volume given that you want max. So you want to maximize this thing. You can find that. You can find the max volume. Whether it comes out exactly, I don't know. Maybe it does, maybe it doesn't. Because you're after exact values. Take a risk. Maybe it does. But if it doesn't, think about this. You know that x is between pound 4 and pound 2. You also know that for this thing to be 0, you need one of the zeros on top. One of the things on top to be 0, right? So immediately, cos x is out, sine x is out, because neither of them would be 0 between pound 4 and pound 2. So you're left with this term, 3 cos squared x minus 1 equals 0. So you do, okay, 3 cos squared x minus 1 equals 0. Cos squared x equals 1/3. So cos x equals 1 on root 3. X equals inverse cos 1 on root 3. That's the only possible 0 to have. Now, what would be a smart thing to do would be just to check whether the denominator has a problem with that. Remember, if the denominator is 0, you're going to have problems. Well, cos squared x equals 1/3, right? So if you put that into the bottom, you'll see that no, you don't get any zeros on the bottom. It's fine. So x equals inverse cos 1 on root 3. You'd find that one way or another. And with that, plug that into your calculator for t, and you'll get 4,000 root 3 over 27. And that is your answer. Again, this is not a difficult question. Not at all a difficult question. For 4 marks, it's actually very easy. You know what to do, right? It's not a difficult question. You find the TDX, find where the TDX equals 0, plug in, and then you plug that value in to find t. None of it is difficult. The only difficult part is that perhaps the equation looks a bit long and scary. But I hope you can see that when you're looking for a 0 and you've got things multiplied by each other, it's really easy. You just one of the top 3 items has to equal 0. And in this case, only one of them could equal 0. So yeah, that's part E. Part F is not hard at all, actually. Oh, sorry, before I go into part F, you should just check that your answer, just check that your answer is within your allowed range. You'll find in this case, yes, it is. And that's the only one you'll see in the allowed range. Okay, so again, part of the process to check your answers so that you don't make silly mistakes. Get your answer out, check that this is exactly what the question's asking, and so on. So, sorry, I forgot to move this thing. Anyway, we're up to part F, the last part of question 3. Do you want to know how many people got 0 for this one? No, sorry, I didn't write that down. Can't tell you. But you know that T for F, because it's half the volume, isn't it? Half the volume. So 2000 root 3 over 27. And you can stick that value in, solve it, see what you get. You're going to get x equals 0.81 or 1.23. Yeah? It's just some easy calculator work. Not too difficult at all. Part F should be a cinch if you were able to get part E. So we've come to the end of question 3, and again, look, it's not hugely difficult. I just want to emphasize it's not hugely difficult. None of it is, there's nothing that blows you out of the water. What's difficult about this question is that the equation is a little bit longer, perhaps, and also that the earlier parts require a little bit of visualization. But to be honest, I don't think this is such a difficult question because it walks you through it, and also because your calculator makes life a lot easier. Okay, we're up to question 4. How are we all feeling? We could take a break now, or we could take a break after question 4. Hands up for now. Press your hands up thing. So raise hand if you want a break right now. You feel like a break now. Okay? Okay? Looks like now's a break time. Great. Okay, so when we come back from break, we'll go through question 4, and then we'll go through the multiple choice, and then we'll finish and deal with any questions you have. So again, 5-minute break. I know it's pretty intensive, but we're almost there. The hard part is over. I promise you the hard part is over. Question 4 after the break, and then multiple choice. Okay, I'll see you guys in 5 minutes. All right, we're all back from the break. Maybe I'll give you guys 30 seconds to settle down and stuff. We're all feeling okay, hopefully. We're 2 and a bit hours in. Less than an hour to go. Less than an hour to go. So I hope we're all feeling really awesome about everything. And I've got a question in the break just about timing, about what to do during reading time and stuff like that. So firstly, onto timing. I like to, or when I did these, and also now if I have an exam to do and stuff, I like to think of just where I want to be at certain points of the exam. Of course, it's good to establish this during reading time. At this point, I mean, in this exam you got 14 marks left out of a total of, what, 80, I think. And, you can divide evenly and stuff, but the hope is that you make up time on the multiple choice, and you're always ahead of your time targets, if at all possible. So please set yourself some time targets. And, if there's nasty questions, leave them for later. But, if there's easy questions, knock them down now. Yeah, so at this point, I'd say you've got 120 minutes for your exam, so you're at 2 marks. What is it? 3 marks every. No. You're at okay. So you need 120 marks in 80 minutes. Sorry, 80 marks in 120 minutes. So you're looking at less than 1 mark a minute, but 2 marks every 3 minutes. That's what I wanted to say. 2 marks every 3 minutes. And so you can cut your time down like that. As to what to do during reading time, read through briefly. Just have a feel for the difficulty of the questions. If there's any questions that you just think of, what is this going on? What are they even asking? Reading time is the time to sit down and just stare at the question until you know a little bit about what's going on. If you really, really need some clarification, ask the examiners. Perhaps they may or may not help you with something. Reading time is good for that kind of thing. I generally don't recommend starting multiple choice in reading time unless you don't have anything else to do. If you don't have anything else to do, just start reading through the multiple choice. Start picking out some answers and remember them. Right? You can't write them down. Remember them. When you come to them, just tick them off. Really easy. But what I would like to do, what I prefer to do during reading time is actually look at the long questions, think of which questions I'll have trouble with, and work on those. So yeah, with that, let's begin question 4. So, question 4 is about some function. It's good. This time around we don't have a story of sorts. And it's actually not very difficult to start anyway. So the first one, part A, you get given some function. It is a quartic. There's you see that there's a cubic bit and then a linear bit, right? So you know immediately, there's going to be a stationary point of inflection and then a linear part. So use your calculator, solve that, because you want to find the x-coordinates of each of the stationary points, right? So go ahead, graph it, find the stationary points, and very simple. I'm going to leave that to you. At x equals half, there is a stationary point of inflection. And then at x equals 13 on 8, there is a local maximum. Don't just say maximum, say local maximum. You could also actually infer this, or not the two stationary points themselves, but certainly, certainly what comes after it, just by looking at the equation. So you know it's a positive quartic. You know that you have you've got sorry, you know that you've got one stationary point at x equals half. That's the obvious one, and that's the stationary point of inflection, right? You don't need to go to a calculator for that part. You don't know where the local max is going to be. Sorry, it's not a positive quartic, it's a negative quartic. You're not sure where the local max is, but it breaks. See how you get x equals half, and then at x equals 2, it drops down again. So obviously, it's going to happen sometime between half and 2. And that's got to be a max because, well, we're heading up for this first part, and then we hit that part and goes down. So yeah, you can get 3 of the 4 bits of information without even going to a calculator. Interesting to think about. Part B. Suddenly, you get given some pronumerals. I know a lot of you guys don't like this. You don't like it at all. But the good news is you can just put that into your calculator and it'll solve it for you. So you can put in f of x, right? You can find f dashed of x, and then you can find where f dashed of x equals 0. It's all super easy, you know? You can stack your functions up. You go solve derivative of this thing equals 0, and you can type them in. Although, one note, for TI-89 users at least, AX is not the same as A times X. Don't do AX, because that means other stuff. And you're not going to get one of the answers if you do that. Do A times X. So A times X. When in doubt, just use the times thing. And so, basically, you can use this method to go ahead and find it, and it's 3 marks too. It's a really easy 3 marks, I must say. And you're going to find that for this function, right, so f of x equals 1 on 27, ax minus 1 cubed, b minus 3x plus 1. For this function, the stationary points are at x equals 1 on a, and x equals ab plus 1 over 4a. Good, isn't it? Be very thankful for your calculator, but use it properly, otherwise you will get penalized for it. Part C goes, for what value of a does f have no stationary points? Pretty easy. No stationary points. No stationary points. Well, look back at the function. Clearly you've got, you know, a cubic bit and a linear bit, right? But if you set a equals 0, that takes out your cubic bit entirely. You've only got a linear bit if you take out a, so that's never going to have any stationary points. The only possible value is actually a equals 0. Simple. Or if you look at the answers above, you'll see that, so that's not 1 on 9, that's 1 on a. That's my very poor handwriting. Look at what happens above. You get undefined for a equals 0, right? Because it assumes that a has to be there. If a is not there, none of this stuff would apply. So a equals 0. Really simple. And part D, find a in terms of b if f only has one stationary point. This is not a hard question. 83% got 0 because they didn't know how to start. Okay. You may not know how to start either, but you know how to think. And you can think about this question in an intelligent manner that other people can't. So, if there's only one stationary point, what's going on? Well, obviously, the two stationary points have managed to get themselves onto the same spot, right? So remember that we had 2 stationary points. One from that cubic section of the graph, and the other from the linear part, sort of. And that cubic one was easy to pick, and the linear one, not so much. But, you know, they change according to, you know, what A's and B's have, right? So this one's, think of this one as the cubic one. this one as the slightly linear one. And of course, they can change as value of A's and B's and stuff. If you only have one stationary point, it's likely that they're actually going to be the same. So basically, you just say, okay, well, a reasonable thing to say is that, well, if they had one stationary point, obviously these two are going to be the same. Yeah? So if you were to do that, you'd say, great. You can multiply both sides by 4a, and you can cancel out some stuff, and you'll get 4 equals AB plus 1, and so AB equals 3. A equals B on 3. There. Done. A equals B on 3. We're happy. Very happy. Okay, part E. Again, testing your knowledge about functions. What's the maximum number of stationary points that f can have? Well, like we've said, the cubic part takes up one stationary point. I don't care that it's a cubic and it could have 3. The fact is that it's written in that x cubed kind of form, so it's only ever going to have 1. So you get one stationary point from that and one stationary point from that linear part. So the answer is 2 stationary points max. And actually, there's a real giveaway, because in part B you are asked to find the possible values of x for which you get a stationary point, and you came out with 2 answers, 2 possible answers for any a and b, right? 2 possible answers, and so that corresponds. And part E can get 2. That's 1 very free mark. And so actually, question 4 is really simple. A, B, C, D, E. And then comes the killer. F. I will admit to you that F is a genuinely difficult question. Genuinely difficult. So difficult that 3% of people who took it last year got full marks. A very large percentage got 0. Okay, and so this is how we're going to think about it. The question goes, helps if we put it up here. Assume there is a stationary point at 1, 1, and another stationary point, P, P, where P does not equal 1. Find the value of P. Okay. Not pleasant. Where to start? Where to start? Okay. There's our trusty methods so far, which has worked for us, are 1, draw a diagram. 2, write facts. Draw a diagram. Not hugely relevant in this case. I mean, your graph will change for different values of, A and B and stuff. And so a diagram is not going to be a huge amount of use to you. What about facts? What are the facts? Okay, you know there's a stationary point at 1, 1, and there's another one at PP. So maybe let's write down some facts, shall we? Let's go, okay, so if it's PP, you know that f of P equals P. And keep in mind, just so that we know what's going on, f of x equals 1 on 27, ax minus 1 cubed, b minus 3x plus 1. That's our f of x, right? So we know that f of P equals P. We also know f of 1 equals 1. What else do we know? In fact, we know a lot of things. F dashed of 1 equals 0. Right? Stationary point at 1, 1. F dashed of P equals 0. Stationary point at PP. Okay. So this is where you need to show yourself something. You sit down and go, okay, fine, I've got 4 pieces of information. I may or may not use them all. Maybe I will. Let's go ahead. Let's, well, clearly, you know, the function is defined by a and b, right? Set values of a and b to do stuff. And you know that, you know that there's a stationary point at 1, 1. At 1, 1. Now, if you go back to part B, you know that stationary points at x equals 1 on A and x equals AB plus 1 on 4A, right? You know that from part B. At 1 on A, let's make our life easy. Try. And I say try because it may or may not work, but it's worth a try. Try that A equals 1. So you know there's a stationary point at x equals 1. Yeah? So essentially you've just said, all right, well, I know there's a stationary point at 1, 1. Maybe if I just stick A equals 1, let's see what happens. F of 1 is what? 1 on 27, A is 1, remember? And then x equals 1. So this part comes out to nothing. Plus 1 equals 1. Oh, look, it fits. You see that A equals 1 will fit. That's a good start, good sign. So let's tentatively stick with A equals 1, shall we? A equals 1. Okay. Now, if A equals 1, then P, which is our other stationary point, remember our other stationary point is at P. So at x equals P, let's do it. We know that the other stationary point is at x equals AB plus 1 on 4A. If A equals 1, then you get B plus 1 on 4, right? That's the other stationary point. Okay. And you know that, well, the other stationary point occurs at P. At P. So x equals P, f of x also equals P. Give me a drink. X equals P, f of x also equals P. So, okay, let's stick this in. So, that means P is B plus 1 on 4. That's the first bit. And you know that f of P equals P, right? So, if we want to do f of P equals P, you get, well, f of P is 1 on 27, P minus 1 cubed, B minus 3P plus 1 equals P. Yeah? And then, look what we've done. Look what we've done. We've come up with these two equations. P equals B plus 1 on 4. And then, f of P equals P. Can you see that you can P, you can manage to sub B out of this? You can put this equation in there and then solve for P. Oh, look. The question says find P. I think we are getting somewhere here. We're definitely getting somewhere. Okay. So let's sub that little equation to the big one. The variable you don't care about is B at this stage, right? So get rid of B. So if P equals B plus 1 on 4, well, 4P equals B plus 1, B equals 4P minus 1, right? So let's do that. So you go 1 on 27 p minus 1 cubed, 4p minus 1 minus 3p plus 1 equals p. Oh, look. Does that look like an equation you could solve? I think the answer is yes, very much so. So, let's tidy things up a little bit. 4p minus 3p is p minus 1. Oh, look. Plus 1 minus p equals 0. And if you like, just stick that into a calculator, or you could be really nice and do something like this. If you were to put that into a calculator, you'll find that p equals 1 or p equals 4. And p equals 4 will be your answer. Do you see how we went about going that question? In all honesty, there was a little bit of guessing. This part. I said try. Because it may or may not have worked. But if it didn't work, I would know that, okay, well that means the other one must be that. And I can go from there. Okay, here you have to try. I tried and it worked. And it was sort of like the obvious thing to try. And then what happened? We saw that we had an opportunity to make two equations that could get rid of b, and then we could solve for p. See how that happened? It wasn't hugely obvious, perhaps. But once it got going, it helped itself. It helped itself a little bit. And so here we're able to see that, well, we were able to come to an answer in the end. So yeah, there it is. The long answer section is out of the way. Okay. It's 20 to 6. I don't want to take another break. I think we're feeling pretty good about ourselves so far. Let's get on to the multiple choice, shall we? Let's rip into the multiple choice, and then we'll finish up for the day. I'm feeling tired too. But we'll push on with you guys. It's all good. Okay. So, back it up to the top of this section. And let's talk a bit about this multiple choice section. I think the way I'll go through it is that a lot of these are really simple. I'm going to spend minimal time on them. If you're not happy with a question, put up your hand and or type me a question or something, and I'll try to answer. Oh, sorry, I missed the question before. Maybe I'll just quickly answer that. Oops. I see that this is from a long way back. Sorry about that. Look, the question was about, let me see if I can find it. The question came from question 3, actually. And it goes, I think we're talking about this part. Oops. We're talking about, okay, 3 part D. And the question was, I thought when you put cos x squared into the square root into part D will become cos x to the power of 4 minus 2 cos x to the power of 6, not square root. Not square root cos x squared minus 2 to the power of 6. Okay, so the question is about this bit. Let me find that. Question's about this part. This line here. Yes, you're right. You want to see cos x to the power of 4 in there, because the cos squared, right, remember what we're doing with this? The cos squared, when you put that into the square root, you have to square it. So it's cos to the power of 4. Sorry, I must have missed something. On my little page here, I think I wrote 4, but it was not very clear. That's definitely a 4 there. Sorry to be very confusing about that. Thanks for asking the question. Awesome. Okay. So yeah, back onto multiple choice. We're good. So I'll pay more attention to questions next time. I know that sometimes I get carried away. I don't look at this thing. So anyway, carrying on. Okay, multiple choice. So again, with these questions, I don't want to spend too much time on things that, on the items that don't, on the items that, you know, are pretty easy. I want to give some time to some of the questions because some of them are indeed tricky. So let's get into it. Multi-choice. 1. Okay. The first one, you get a function with some period, or some function, you want the period, right? Period, pretty easy. For tan, it's pi on b, right? Pi divided by 1/3, 3 pi. The answer is D, happy. All right, so raise your hand if you're not happy. I'm going to go through this quickly. Question 2, average rate of change for this function. Remember average rate of change, what's going on? You write down the 2 coordinates and then you find the gradient. So at x equals 1, f of x equals 3. At x equals 5, f of x equals, use your calculator or otherwise, 135. Gradient is rise, 132, over run, 4, 33. I did that with no calculator. You could do that with a calculator. That's fine. D. Sorry, not D, E. Trying to be neat here. E. Yeah. Question 3. Range of this function. Okay, we were using an absolute sign, absolute thing, which means that that thing cannot drop below 0. Can it equal 0? Look at the function inside. Yes, very much so, right? So you know the lowest value this thing can reach is 3. And what's the highest? Well, anything, isn't it? Infinity. So it's 3 to infinity. A. Question 4. Get some f of x going and g of x. And you want g of f of x. Well, unfortunately, you're going to have to write it in. So g of f of x says this. Log of 2. Instead of x, you put in f of x. Half e to the 3x plus 3. Right? Okay. So the 2 and the half, they cancel out. You know that if you do log to the base e, and then you put an exponential inside, they also cancel themselves out. You get 3x plus 3. So yeah, all of the inside here blows up to become just 3x. Nice, isn't it? Nice to see how most of the equation is useless. 3x plus 3. And you look at your answers, the only one that looks like 3x plus 3 is D. Good. Question 5. Flying here. Okay, simultaneous equations. Equivalent matrix equation. Okay. What is the easiest way to do this? You have to try to pick through whether each one is right or not. Look, let's do this. You know that x equals 5 means that you need, on the top line of the matrix, well, first of all, you need a matrix that sort of looks like correct. So you want this kind of setup, right? So immediately you know that, well, A is incorrect. C is potentially correct, maybe. So you want something that looks like that. The first thing also you don't want to know is that x equals 5. So the first line should be 100, right? 1 times x, 0 times y, 0 times z equals 5. 1005. So for 100 you get b and d, and then you say, okay, good. What about the second line? Z plus y equals 10. Z plus y, you should have 1 and 1. So it's the second row on that matrix, you should have 0, 1, 1. No, not the case for D. The answer is B. Easy. So yeah, if you have multiple clues and multiple answers, which you will in a multiple choice, pick the easiest clue to cut out some options and keep going until you get the rest. So yeah, I didn't have to look at the third line at all, and I was able to just pick between B and D. Made my life simple. Question 6. Function G. There you go. So you want G dashed of X, and then you want to find C, right? So very quickly, you can do the integration. Don't use your calculator for this. It's a waste of time. Very, very simple. G of X is 1/3 X cubed minus X squared plus C, and then it goes through the point 1, 0. So 0 equals 1/3 times 1 minus 1 plus C. C equals 2/3. Right? And so you look at your answers, and actually you probably should have had a quick look at the answers beforehand. So you know that it had to be either, well, B or C, right? So you work out your C, okay, C is not 0, C is 2/3, and you go ahead with C. Pretty simple. So yeah, it's a mix of looking at the question, look at the possible answers, and then work out as little as you need to. It's a lesson you have here. Okay, 7. You get simultaneous equation, have infinitely many solutions. Notice, okay, infinitely many solutions for m equals some value, right? Okay, notice that they're both straight lines. Want you to notice something else? That for straight lines to have infinite many solutions, you need the two equations to be exactly the same. So you need equations, you basically need them identical if you want infinitely many solutions, if you have two straight lines, right? So for infinitely many solutions, you can see that A, B, and C are definitely not going to make sense because only one value potentially is going to give you anything. It's not like you can throw any value out there and get two straight lines to match exactly. It's not possible. A, B, C are out of the race immediately. So you go, okay, good. You can say, well, if they're the same line, then the coefficient of X must be the same as the coefficient of Y, must be the same as stuff. So look at coefficient of X. Sorry, the ratios have to be the same. So the coefficient of X is m minus 1 in the first one, divided by the coefficient of X in the second one is 3. That ratio has to be the same as coefficient of Y in the first one, and then coefficient of Y in the second one. And again, this ratio has to be the constant in the first one, constant in the second one. Okay? So there you go. Three things to put together. Pick whichever one is easier. I'd say pick the last two to solve. So you go, great. Okay. You can say to yourself, you flip them first. Eh? No, don't need to flip them. No, just cross mod. Yeah, flip. Okay. So m minus 3 over 5 is 7 on 0.7 m. Oops. 0.7 m over 7. Zero 0.7 m over 7. There you go. Okay, so you multiply the left side by 7 m minus 21 is equal to 5 times 0.7, right? 3.5 m. Okay, so you collect the like terms, you get 3.5 m equals 21, m equals 6. There you go, that's one of your answers. Very good. D. Notice that there was no easy way to pick between D and E. Not that I could see anyway. And so you were kind of forced to work it out. I couldn't see an easier way of doing it. So yeah, there you go. That's 7. 7 did take a little bit more time than the rest, but I have to say that the first 6 were very easy. 8. You get a function, and then you go f of 5x equals log y, then y is equal to something. Okay, good. Maybe if you're not sure what the question is asking, just find out something like f of 5x. It would be smart to write that down, don't you think? F of 5x equals, well, just get f of x and then stick 5x where f of x is. Equals 3 log, now 2 times 5x, 10x, right? Okay. That has to equal log y. So it has to look like log something. But you got 3 log. Use your log laws. You know that you can do this. 10x and then cube the whole lot, right? And so, what do you get? If you cube the whole lot, 1000 x cubed. Good. Good. E. There you go. Question 9. Okay. Question 9 is very much a calculator type question. What you do is you say, great, we're cutting off the function so that we have an inverse function. So essentially you're looking for, and you look at where the function is defined from negative infinity to a. And you want to cut off so that you have an inverse function. So essentially, go from the left until you have you have a turning point, essentially, and that's all you need. So, graph the thing, find yourself the turning point, the leftmost turning point, and then you have the answer. In this case, you'll find that the leftmost turning point occurs at x equals 0, so you want a smaller than 0, and that's option A. Easy. Very easy. I'm not going to show you how to do stuff on a calculator. You can already do that. Okay. Question 10. Yeah, I know I'm trying to squeeze myself for space. But question 10, again, is really simple. Average value of some function closest to something. Well, you know how to find average value, right? Well, it's over 0 to pi, isn't it? You do 1 on pi, 0 to pi, e to the 2x cos 3x dx. Stick that into your calculator. And you'll get C. You will. Notice the average value can be negative or positive. Average value doesn't care if you cross the axis, if like the areas cancel out and stuff. None of that actually matters because you're looking for average value. You're not looking for physical areas. See, physical area is some kind of physical representation, but average value has nothing like that. Okay, so there, 10 questions out of the way, and we've spent how long? Oh, 15 minutes. 15 minutes. Good, 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 good. Very happy about it. Very happy with ourselves. Hold it on. There's 22 multiple choice questions, and we're up to 11. We are halfway, guys. We're almost halfway. Almost halfway. Okay, question 11 says this. Question 11 talks about probability distribution, right? And you want some value of A such that probability is 0.25. So basically your A is, yeah, I'm drinking some water. I'm starting to lose my voice, but this will be almost done soon. Okay, so your A is going to be a terminal on this thing, on your integral, right? So probability of x smaller than A is 0.25. Set up your integral like this. You've got integral between where 3 pi and 4 is the lowest value possible, A, and then cos 2x dx equals 0.25. Set that up. And you could solve it. I stuffed it up when I did it on the calculator, but maybe you guys are better at that. You could solve it directly with your calculator, or you could sort of just test it out, trial and error style. If you decide to go trial and error, you should start in the middle value, so C, and then you test outward from there. But it so happens, right, that if you put it in, you'll get A very close to 2.88. And so you wouldn't bother. You just go, great. Answer is C. Okay, 12. Probability question. Really simple. You know how to do this on the calculator too. You know that X, so this is just our thing, our variable. X is what? Number of goals, right? Distributed binomially. Probability of success is 0.6. Number of trials, 15. And you find probability that scores less than 7. So X smaller or equal to 6. You'll find 0.05950. B. Straight calculator question. Don't really need to explain. 13. All right. 13, we're talking about standard normal, mapping your normal distribution to the standard normal. Okay. Z between -2 and 1. Okay. Well, so you can map your Z to X, right? So you know that for some people it helps if you do Z equals X minus mu over sigma. And so let's do that. And you say that, okay, at Z equals, at Z equals -2, you get -2 equals X minus mu 20 over 6. And then at Z equals 1, you get X equals X the same, right? So let's say X1 and X2, shall we? So you're going to find two limits for X, not limits, so it's two values for X where, you know, it should be between. If you were to go ahead and solve this, you'll find X1 equals 8, X2 equals 26. Great. So you conclude that probability X between 8 and 26. And then you look down at the answers and you go, oh crap, that's not there. Have I done something wrong? Maybe you have, but this is a pretty easy calculation. It's not something you may or may not have done wrong. And you go, okay, look, there's other options in here that may or may be correct. This is where you draw yourself a diagram. Diagram really helps here. The diagram you draw is of the normal distribution, of course. And basically you go, okay, the mean is at 20, right? You've managed to get 26 and 8. Like that. So you're after the area between 26 and 8. do you also see that there are other values on this thing, and that this area, let's draw it in green. So 26 and 8 is what you came up with. This area is actually the same as this area, 14 to 32. See the distance along here is 6, 6, 6, 6, right? Symmetrical distribution. 8 to 26 is the same as 14 to 32. And you see that part B? Yes, that's what you have. In reality, when you approach this question, there's not much use looking at the answers first up, except that E is incorrect. The best thing is to look at it. If it doesn't match, find somewhere else on the normal distribution that may match you. And from that, you'll see that the answer is B. Okay, 14. Home stretch now. 14 is really easy. 3 balls drawn without the bag, without replacement, with 4 white balls, 6 black balls. Probability they're all black is. Okay. Well, so you got to find the probability of drawing a black, and then a black, then a black. Probability of drawing a black, first up, is 6 on 4, isn't it? Sorry, it's not 6 on 10. 6 black, 4 white. Okay? But after that, you're not replacing. So you got 5 black and 4 white. So you got 5 on 9. And then 4 on 8. You're all pretty familiar on how to do that. Put that into your calculator, you're going to get 1/6. And so 14 is A. Easy. 15. Probability distribution. Mean of X is 1, then what? Okay. So you know the expected value, you get some A's and B's, right? So expected value, perhaps that's good to write down, is, well, 0 times A, don't write that, it's not useful. 1 times B plus 2 times 0.4. And you know that the expected value equals 1. So B equals 0.2. Yeah? For that equal 1. For expected value to equal 1. B equals 0.2. Okay. Also, as a side note, if you looked at the answers, you'd probably see that, okay, 2 of the B's equal 0.2. That's probably something. B equals 0.2. Okay. You got 2 options to A. 0.2, 0.4. You know that the sum of probabilities need to add up to 1. So, if B equals 0.2, A better equals 0.4 for things to add up. Right? All the probabilities have to add up to 1. So, with that, you should be satisfied that it is C. Question 16. Gradient of the function is negative for some value. Okay. Graph it. Simple as that. It's not a very hard thing to do. When you graph it, you'll see a graph that looks something like this. Oops. Didn't register. Like that. There we go. And, oops, sorry. Undo. It doesn't actually look like that. Oh, sorry. It does. Oop, oh, crap. That's a no. Sorry, it does look like that. Second guess myself. Looks like that. Oh, crap. Okay. And you want negative gradient. Notice that negative gradient is obviously this part and that part, right? Notice that of the answers, the only ones that look like X smaller than something and x bigger than something is D. And so do D. Don't even think about finding out what it is. Negative root 3, irrelevant. D is the only answer that looks even semi-correct. Because you're looking for negative gradient, and clearly there's two regions of negative gradient, and only one of the answers describes two regions. 16 is D. Okay. We're happy? We haven't actually come across a particularly difficult one yet at all. 17 gets it up there a little bit. Not heaps, a little bit. Let's talk about 17, shall we? 17 says, well, you get a function, differentiable, and then you get some conditions, right? So the, gradient is something at some point, and then you ask, which one of the following is true? Okay, notice that you get contradictory statements. A, B, and D are all contradictory. C and E are also contradictory. A, B, and D, there's three things, so let's look at what goes on at x equals 4, shall we? At x equals 4, we see that at x just smaller than 4, so between 2 and 4, you get positives gradient. At 4, you get 0. And then at x bigger than 4, you get positive again. So you get stationary point of inflection at x equals 4. There, B. Done. Not too bad, is it? Not too bad at all. If you want to feel secure about yourself, check out what goes on at x equals 2. At x equals 2, you get, well, f dash of x is negative for x smaller than 2, 0, and then positive. The minimum at x equals 2, and that's clearly not one of the options. So that's just a double check because you caned it so hard on the first part of the question. So be very happy with yourself. Write down B for 17. 18 is interesting because which of the following is true? Again, all the good stuff is C, D, E. Right? Clearly there's stuff going on at x equals 0. But what goes on? You could draw a graph and have a look and zoom it up. Or you can just think about it. E to the x looks like this, right? So it kind of looks like that. Kind of looks like that. And if you were to sort of do the opposite, do that. And that's what our function is going to look like, isn't it? I mean, covering it up. Close enough. You get sharp part at x equals 0 because the gradients aren't the same. One gradient is increasing, one gradient is decreasing, and so clearly it's sharp. Is it continuous? Yes. Continuous means whether it's defined or not. So yes, it's continuous. Differentiable? No, it's not. Stationary point? Oh, it is not a stationary point. Both of these things don't have stationary points, and so you can't combo your function and have a stationary point. D is your answer. Not differentiable because it is a cusp. So you got the two, you can see clearly that the two gradients are different, right? One gradient is increasing, one gradient is decreasing. You get a cusp. And so question 18 is D. Okay. We'll be on to some really interesting questions really soon. Question 19. No, question 19 is still easy. So you get given f dash of x, and you need to make sense of f of x. Good stuff. Okay. First of all, f dash of x is a cubic, isn't it? It's a positive cubic. If you integrate a positive cubic, you get a positive quartic. Which one looks like a positive quartic? D. Don't need to think. Don't think too hard on these. another way to do it would be to say, well, let's break it up into regions where we're positive and negative, and then try to match positive, negative. So in this case, draw the axis in. You get what goes on. You get negative gradient for here, positive gradient for this part, negative gradient for this part, positive for this part. So you want a graph that goes negative, positive, negative, positive. And the only one that would do that is, again, D. So yeah, alternate way of looking at it. But yeah, the first way of thinking about it is certainly quicker. Okay. Question 20 is an interesting question. This is where we get to the business end of things, where you feel like you're quite ahead of time and stuff, and you know it's all pretty good, but yeah. Then you get thrown one of these, you're thinking, wow, what's going on? What's going on? What's going on? Okay. So you get given an integral of f of x over 0 to a, and that's supposed to equal a. And then you get stretched. So maybe let's focus on this second part, right? So they're asking for this. They're asking for that. Okay. Clearly the troublesome part is f of x on 5. Let's isolate. So that's just f of x on 5 plus that second part is really easy. You can deal with that. This first part is interesting. Let me draw a graph. Maybe this will help visualize what's going on. See again? When you're not sure, draw a picture, okay? Draw a picture. So you don't know what f of x looks like, but I'm going to assume it looks something like this, okay? This is a. And we say that the area is a, too. This is f of x. Good, isn't it? So you would agree that the average value equals, well, 1 on a times the integral, 1 on a times a, 1. That's the average value, right? Good. What do you do when you have f of x on 5? You stretch it out by a factor of 5, right? Dilation of factor 5 from the y-axis. So it looks something like this. It stretches itself out. It does that. Something like that. Anyway, this thing here is now 5a. Has the average value changed? Hasn't, has it? Remember, with the average value, you sort of like feel it a bit, right? You feel it and you sort of go, well, this above part, let's just throw that in there and it's all going to fit nicely. You feel it a bit. So here, the average value equals 1, and so the area equals, well, the average value times the length, right? So 1 times 5a. So this is f of x on 5. And in case you're wondering, the area in here, this is the integral from 0 to 5a of f of x plus x on 5. And we're saying that it is 5a. That's a little bit intuitive for some people maybe. But I wrote that in just to convince you that that's true. That the average value of your function won't change when you stretch it out, right? Doesn't change. So you come back here and you say, sorry, I should put dx in here, I missed that. Say, great. So integral of that part is 5a. So I get 2 times 5a plus, now, 2, 3x, 5a to 0, 10a plus what? You put in x equals 5a, you get 15a times 2, 30a. 40a is your answer. D. Amount of interest, 25% of people who did the exam last year got it. They weren't happy with this concept, that the average value will stay the same if you stretch your function. But it does. So there. That one is one that would have taken some time. I'd probably expect a lot of you just to like leave it and maybe come back to it later. Okay. 21. Real easy one. Mutually exclusive, PRA is P, PRB is Q, and stuff. You want not A and not B. This is where you draw a Venn diagram, right? Think back to like year 10 or whenever you learned this. Notice that they're mutually exclusive. What does that mean? Mutually exclusive means cannot possibly happen together. No overlap. This is P, this is Q. So, what do you want? You want probability of not A and not B, so the outside area. You're interested in the shaded part. And the shaded part is very simply 1 minus Q, 1 minus P minus Q, and you look at your answers, you go, oh, that's really good. Cool. C. 21 is the easy one. 22, however, 22 is a beast of sorts. It's not really anything you can look at and think, yep, got it, great, really good. Really good. Okay. The way I looked at this was, wow, this is a rough question. How can you begin? So what I did was I said, okay, let's sub in some values. Let's sub in some values. Let's sum in some values and go, well, okay. Maybe I'll just say let A equal what? Maybe 2, B equal 3. Okay? This is the thought process I went through. I thought, what the? And then so I decided, okay, great. Let's think. AB. So AB plus 2 is 8. So it's saying that the integral from 8 to 3 is equal to the integral from 4 to 3 plus the integral from 5 to 3. Yeah? So do you see that you get this kind of, well, this integral from 8 to 3 is, it's longer, so it's sort of like, think of it as, well, you're after 5, from 3 to 8, that's like 5 units, right? And then you can cover that with 4 to 3 plus 5 to 3. So it's kind of like this. If that's 3 and that's 8, you can say, and so let's say my function is, I don't know, let's just call this my function, right? You're saying that area A, so let's call the whole thing, this whole area is equal to, that's 4 and that's 5. It's equal to 2 times that plus 1 times that, right? Because obviously, you know, this second part, you can write it as 2, 4, 3 f of x dx plus 5 to 4 f of x dx. Yeah? 2 of these plus 1 of that is going to give you this whole area. Maybe it helps if I draw it almost to scale. So there you go. So do you see that if I sort of just like shift this so you get 2 of these. So let's maybe double this and you'll get that. So we're saying that the whole area, the whole thing, is equal to the red bit plus the green bit. Sorry, I need to use more colors. The whole black part is equal to the red bit plus the green bit areas. That's what this thing is telling us. Meaning, we are decreasing. This function decreases. In a very rough kind of way, this question decreases. This function decreases as you get from 3 to 8. You can ascertain this because the area at the top is clearly bigger than the area at the bottom. Look for a function that will decrease over from 3 to 8. So you can look at square root, that increases, log increases, 1 on x minus 2 decreases. It's e, 1 on x minus 2. That's obviously not the only way to go about it. You could just test with some numbers and test these options. I suggest question 22 be one to leave almost to the end. It's not an easy thing to do. To convince yourself in your mind that it's a decreasing function is also not a hugely easy thing to do either. So I think, yeah, 22 is the only question on here that I would say is rough. To be honest, it's a rough question. Rough question, but you know, it's one of these you need to separate the best from the very best somehow, and that's how they've chosen to do it. So I hope you can see this. As for how to like apply my method to doing it, I'm not sure how you'd do it. But what came to me was like, well, sub in some numbers and see if you can make some conclusions. And perhaps that's a good way of going about things when you really have no idea what's going on. Okay, so I've managed to come to the end of our time on the exam, which is really good. I can see that there's some questions I haven't quite answered. Sorry, I'm not very good at paying attention to questions when I'm writing stuff. So, yep, okay. Cool. Actually, there's only one. And this guy says, whenever you can answer this, I was wondering whether it's better to bring in the textbook with annotations to bound reference or just make your own. Thanks. Well, my opinion on this is that the textbook, there's nothing wrong with a textbook as a bound reference. It's certainly bound. It's certainly a reference. But whatever you use, you need to be familiar with where stuff is. Bring your textbook if that's the one that you've always looked at and you know exactly what page to go to for stuff and you know where to find stuff you need. Like personally though, I would find a textbook a bit cumbersome maybe, and I'd think that over the year I would have wanted to make my own reference, like a big exercise book where I put stuff in it. but obviously at this stage and you haven't made one, it's too late to begin and be familiar with it. And so if the textbook is something that you're most familiar with, go with that textbook. So I hope that answers your question. Do we have any other questions on this? So we've managed to come to the end of the exam. I realize we're about half an hour over time. I apologize for that. But I hope that it's been helpful to you so far. So, questions? Type now. Quiet. Or hands up if you have a question. Okay, cool. We're doing okay then. So, I'll give you guys one last go. I'll look over, see if I have anything else to tell you guys. Okay, look, I think that's about it from me as well. I mean, from now until your exam, you have, well, how many days? About 10 days, maybe less. I mean, what you can do, go through obviously more practice exams, but think about how to structure your answers. Think about your process at arriving at some kind of answer. Don't just go, I got this question right, I didn't get that question right. Think of why you didn't get something right or why you did get something right. For instance, you know, is it stupid mistakes that's costing me more marks, or is it that there's hard questions and I get stuck at the very start? I'm like, oh, that's 4 marks. I don't know how to start. Well, that's 4 marks down the drain. You know, and work on that. Work on that. There's ways to get over silly mistakes as well. There's ways of checking your work so that you can not make heaps of silly mistakes. And one smart way to do it is just immediately when you get an answer, go back to the question, see if your answer makes sense. And yeah, as for you know, how to approach a question, I hope I've demonstrated a few things to you today. So things like writing down the facts that you know, drawing a diagram, or in the case of the very last question we looked at today, you know, put in some numbers if the above fails you. So, you know, for all of these, there's techniques to solve, and, you know, I really wish you the very, very best on your exam. If you have a question of things you're not sure on, you can definitely email me at abe@awesome@maths.com.au. And yeah, I'll definitely try to respond to you in quick fashion because I know that you guys are in a rush. Okay, if there's nothing more, I want to thank you for your attendance. And you know, if you need to, do get in touch with me. Otherwise, on all the very best for your exam. Thank you very much.